Now that we know how to iterate source code through Android Studio Debugger and how to inspect the variables, it's time to move on to something more complex. The first thing we want to look at is the method stack or the call stack. Before we do that, I've added a method here at the bottom. It's a binary search method. It's a little bit contrived as I've set the size to 2 million and it really doesn't do much but find the value that I pass in. How it's populated is every index of the array that I'm storing my values in contains the actual index for that array. If it's index 0, for instance, the array index of 0 will contain the value 0. If it's array index 25, array index 25 will contain the actual value 25. It really doesn't do anything useful at this point. I could give it values from another source, obviously, and then make this useful, but I just want to show how the call stack works. So this method is called search. I want to put a call to that method within my calculate_sum method. I'm also going to add a breakpoint to the first line of this search method. Now I'm going to debug, and we can switch over to the Android virtual device. Now this time, I'm really not interested in the calculations. I'm really interested in just activating that code. And since I already have a button handy, I will just leverage that. So I will go ahead and type values and then press calculate to activate the code. Now you can see the code stopped at the breakpoint we had before, the first line of calculate_sum. If I bring up the bar here for the debugger, you can see it better. And I'm just going to step through the code. I'll step once, and now I'm going to step one more time. Now this is the cool stuff I wanted to show you. If we look over here to the left, you'll see at the right there's the variables, but at the left is the call stack. This is how we got to where we are. You can see there is the onClick method that was called. And if I pull this down, you can see the actual view.java code behind that. You can also see some variables attached to that. Then there's some invoke calls using reflection. But then we get to calculate_sum. That was the next method that was called. And if you look to the right, you'll see that those are the values that were associated with calculate_sum at the time search was called. Then if we go into search by clicking it, we have some variables there. Right now we just have the parameter that was passed called subject. And you'll see it's 1200000. If we step through that, you'll start seeing the variables for that method. What's very cool is we can keep going back here if we have any doubt how we got to this point in time. Go through the call stack and go back and forth. If we're doubting that the subject value is correct, for instance, I can go back here and check it. So let's go back to search. And now we have another feature we can do. Let's bring this down so we can see. Say I want to set a breakpoint. We have a lot of values to search through. This array is 2 million. We are looking sequentially for 1,200,000. I want to stop at this point here. I do not want to keep pushing the step over button. So what I can do is once I put a breakpoint at that spot, I can right click and I can put a condition here. I can say when end minus begin, we wrap that with parentheses, is less than 20. That's called a conditional breakpoint. I don't want this breakpoint to activate until I'm pretty close to these values getting close together, because when begin and end get close together on my binary search, I know I'm close to finishing my search. So let's see if that works. I'll go ahead and resume the program. Okay, it stopped at when begin is at 1,199,995 and the end is 1,200,009. So at this point, I know I'm getting kind of close to finding my value I'm searching for with a binary search. So I might start stepping through this. And now the begin is almost to 1,200,000 and the end is 1,200,001. Now you can see I'm very, very close because this is set to 1,199,999. This is set to 1,200,001. We'll step one more time. Let's see, did we find it? If this is equal to this, I want to return. Let's see if I found it. Not yet. And I did that time. So that's a great way to take advantage of using breakpoints in Android Studio.